So here we go with the Chapter 2 measurement review. The test will be multiple choice. You'll have 3 problems to work out. What you should study is this review, your notes, your any worksheets that you got back, and then the quizzes we did in class on Friday. You should work that as many times as you need to until you understand how to do that. So let's get started with question 1. So question 1 wants to know the difference between quantitative and qualitative data and to give examples. So I've written here that quantitative, remember that has a quantity that can be measured. It will have a number plus a unit. So example would be 10 grams, 5 degrees Celsius, 157 kilometers. It's things that can be measured. A qualitative, on the other hand, is data that has a quality that can be observed with your senses. For example, it was a blue liquid, the reaction got warmer. We used the example in class of our Kool-Aid lab. Remember, we observed the qualitative data of that the Kool-Aid separated into 2 different colors, spots, and then we did a quantitative measurement when we measured with a ruler how many centimeters the spots moved. Both are important in our measurements, but they are different, and you will need to know the difference in the 2 definitions. Okay, let's talk about the prefixes because some of us are still struggling with the prefixes. These are the prefixes you need to know for the test. Kilo, deci, centi, milli, and micro, okay? And you also need to know that the base units that we will be using are meters, liters, and grams, okay? The kilo is bigger than the base unit, okay? So 1 kilo is equal to 1,000 of the base. So that means 1 kilometer is equal to 1,000 meters. 1 kiloliter would be equal to 1,000 liters. 1 kilogram would be equal to 1,000 grams. So that's the way that works. The deci, centi, milli, and micro are all smaller than the base, so it takes a lot of them to equal the base unit. And anytime I say base, I mean meter, liters, or grams. So deci is 10 of the decimeters to equal 1 of the base units. If it was centi and you had meters, it'd be 100 centimeters to equal 1 meter. And then milli is 1,000, micro is 1,000,000, or 1 times 10 to the 6. I left these blanks here so that you could fill that in with either meters, liters, or grams and know that whatever one we're talking about, these prefixes mean that many numbers, okay? And then here's our abbreviations for deci, centi, milli, and micro. Remember, if we were talking about putting it as a unit, we would say a centimeter, and we'd put it like that, or we could say a centigram, and we'd put it like that, or we could do a centiliter. So we put those little letters in front of the abbreviation for the unit. So make sure you memorize those for the test. You will not be given those on the test. Any other unit that might show up on the test, like the big, really big ones or the really small ones, I would give you, but these are the ones you have to memorize. So what number 3 was asking is it's just asking you to know what these things are measuring. You do need to know this conversion that 1 centimeter cubed is equal to a milliliter. You need to know that a liter is measuring volume, that decimeter would be measuring length. The other thing would be meter, also would measure length. You need to know that grams is mass, and that meters cubed or centimeters cubed for that matter would be measuring volume. Another thing would be milliliter would also measure volume. Another kilometer could also be measuring length. Mass could be grams or milligrams or kilograms. Those are all things that would be measuring mass. So make sure you know those things as well. So this problem was giving us some mass and a volume, and it told us what the student did to get the answer, and it said the calculator displayed an answer of 0.57, and it wants to know, A, is the setup for calculating density correct? So the way you would check that is you would just literally do a density calculation yourself, mass over volume, plug those numbers in, and when you got that on the calculator, you would see that it does, in fact, give you the same answer. So that answer would be yes, it is the correct setup. And then B wants to know how many significant figures, and it is 2, and that is because of this right here. This one has 2. The 4 grams would be 3 significant figures, but when we're multiplying or dividing, remember we're looking at smallest number of significant figures, so the actual answer would be reported as 0.57 grams per milliliter. So let's move on to the next question. So this question is asking you about significant figures. 4 tells you that in a text, the value is shown as 4,000 grams. So the precision of the number is uncertain. And so A says, suppose that the mass was determined to be 4,000 grams. So how many significant figures are present in this measurement? Because there is no 0, it would only have 1 significant figure. I mean, because there's no decimal, not 0. Because there's no decimal right here, that would be considered to be 1 significant figure. If you are still having trouble understanding that, you need to refer back to the rules and also our flow chart. But remember, when there's no decimal, it means this is an estimated number. And then B says you know that the mass lies somewhere between 3950 and 4050. And if you put that in the calculator, you also get 4,000, just like you did up here. But because of this right here and this right here, both of those numbers have 3 significant figures, you need your answer in 3 significant figures. So sometimes you would need to put it in scientific notation like we did right here in order for the measurement to actually read the correct number of significant figures. So by the fact that we put this decimal right here means that these 2 zeros now are in fact significant. And so now our reported value would match the precision of our measurement. So this is just giving us like a basic problem. If we were to take a sample's mass and divide it by its density, what are the resulting units? So this would be a dimensional analysis problem. So we're going to just put in like just units and not numbers. So if we started with grams and we wanted to divide by its density, we would do like this. We would do our grid, and of course if we want to get rid of density, density would go on the bottom, and then the units would go on the top. So if we're doing grams per centimeter cubed, it would look like that. Okay, so of course when we did that and we canceled out, then we would get a unit of centimeter cubed. If you were doing that with grams per milliliter, it would look very much the same, except it would be milliliters instead of centimeters cubed. So of course your what would be left would be a milliliters. So what you're actually left with in both of these cases is when you take a mass and divide by its density, you get volume. And that is, in fact, the way anytime we're using some sort of sample and we want to go and convert from mass to volume or even volume to mass, if we know the density, we can do that. Okay? So this question is really asking you about precision and accuracy. So they give you the results of 3 students who were determining the volume of a liquid. The known value of the liquid is up here at 24.8. So that would be our true value or our accepted value. And so what it's asking is in question A, considering the averages of all 3 trials, which student's measurements show the greatest accuracy? And since the student C has an average of 24.8, which is the known value, we would say student C, okay? And then B asks us to see which students' measurements show the greatest precision. And so you would look at their measurements and see how closely do they agree. We have 24.8, 24.8, and 24.4. Here we have 24.2, 0.3, and 0.3. And here we have 0.6, 24.8, and 25. So the one that would show the greatest precision would actually be student B, because their measurements are only 0.1 off of each other in trial 1 and 2, and then of course they're the same in trial 3. And then part C wants to know if you know the difference between precision and accuracy. And I'm going to tell you that this is one of the things that kids mix up a lot on the test. So make sure you understand the difference in the 2 definitions. Get them straight in your heads. And that is, accuracy is how accurate are you? Are you getting the real or the true value? In this case, when we talked about the dartboard, that would be hitting it in the bullseye, okay? And then precision is getting the same answer over and over, or repeatability. Can I get the same thing every time? For instance, if you look up here at student B, they got pretty much the same number every time they measured. So they had good precision. Okay, so please, please, please get those definitions straight in your mind. So this is a dimensional analysis problem. It says a single atom of platinum has a mass of 3.25 times 10 to the negative 22. That is supposed to be raised. It says what is the mass of 6.0 times 10 to the 23rd, also supposed to be an exponent, platinum atoms. So I will tell you that your conversion factor is right here, okay? A single atom is that many grams. So you will start with this number, okay? So what I would really like you to do is pause the video, try to work the problem, and then restart the video and see if you got the correct answer and if you set it up right. So go ahead and hit pause. Okay, so based on this problem, you should have set it up like this. Grams per atom here, because it is a conversion factor, and we're trying to get rid of atoms, so we can cross out atoms, and we got rid of that, and now we're left with grams, which is the unit we need. So if you plug that into your calculator correctly, you should get 196. However, we need to put that in the correct number of significant figures. This has 3, but this number right here has only 2 significant figures. So we would need to transfer this number into 2 significant figures. And I look at this and I see that that would bump that up. And so it would actually make it 200 if I bumped it up, but that would not be the correct number of significant figures. So we actually would need to put that answer in scientific notation to get it to be reported correctly. So we would say this is 2.0 times 10 to the 12 grams, okay? And remember, anytime you're moving a decimal into a number that is greater than 1, your exponent is positive. If you are moving it into a number that is less than 1, your exponent is negative. If you are still having trouble writing things into scientific notation, you do definitely need to go watch the tutorial video that is on Canvas. So this problem is on density. It wants you to calculate the density and then determine if it's pure lead, and then it wants you to figure out the percent error based on if it was the density of lead. So I want you to pause the video if you haven't already worked this, and stop and work it. If you have already worked it out, just keep playing. Okay, so you should have gotten a density of 10.7 grams per milliliter. You needed 3 significant figures because of this value right here. I only had 3. Is the sample pure lead? Based on this calculation, we would say no, it's not. That would be unless you made a really big calculation error. And then it asks you to determine the percentage of error. And so again, that formula is accepted value minus the experimental divided by the experimental. And of course, we take the absolute value of that, which means we keep it a positive number. And then you would times the entire thing by 100. If you're doing this in the calculator, make sure you hit enter after this step before you hit times 100. And so when you plug those numbers in, we should get our answer in 3 significant figures, so we would get 6.14%. So you definitely need to know how to figure out how many numbers of significant figures are in a number. And so if you're still struggling with that, you need to go look at your flow chart and the rules. So let's just quickly do these. A is 40 without a decimal. And so the fact that there is no decimal, the only number that would count is the 4. So that would have 1 significant figure. In the next one, because of this decimal right here, that means that all of those figures would be significant. So we would say that had 3. In the following one, whenever you have a 0 in the middle like this, remember we called that either a captive or sandwich 0, and it would count, so it would have 3. And then the last one is the kind that tends to trip people up. Remember, when we have a number that starts with a 0, like this one does, we never start counting until we get to that first non-zero number, and then everything behind there would count after that non-zero number, so that one would also have 3. So if you're still struggling with that, I suggest you just get some numbers and take them, like go through the flow chart and just keep practicing it until you get it correct, until it becomes second nature. Because we will need to do that for the rest of the year, and we always need to determine how many sig figs are in our measurement so that we know what to put our answer in. Okay, so the problems that you're looking at here are, they are just simple math problems, but what I'm wanting to know is, do you know how to put it in the correct number of significant figures when we're doing calculations? And so I want to remind you that when you're adding and subtracting, you are looking at total number of decimal points. So you care how many decimal points are there, and then you match your answer to the smallest number of decimal points in your problem. If you're looking at multiplying and dividing, then you're looking at not decimals, but you're looking at total number of significant figures. And so you match your answer to the one that's the smallest. So I'm going to work the ones for multiplying and dividing in blue, and then I'm going to work the ones for adding and subtracting in red. So this first one, because that 2.3 only has 2 significant figures, we would put our answer as 0.092. And so that has significant figures. The next one is an adding problem. And so if I added those two up, I would see that I would get 2.34. But because that 2.3 only has 1 decimal place, my answer would actually just stay 2.3 because that 4 does not round it up. The next one is division. And because this number right here has only 3 significant figures, I would put my answer in 3 significant figures. So that answer would be 674 is the correct way to do that. And then the last one, subtraction, 20.22 minus 0.03. Because my first number right here only has 2 decimals, I'm going to match my answer to be 2 decimals. So that answer would be 20.19. All right, if you are still struggling with that, there is actually 2 tutorial videos on sig figs on the Canvas. One of them is for recognizing and one of them is for calculations. So you might want to watch through that and see if there's anything that kind of helps you understand it. And then, of course, there's examples that you can always work the examples along with them. So this is a unit conversion problem. I'm going to give you the picogram conversion again on the test. If there was something that's big or small, I would give that to you. I would not give you kilo because that's one you're supposed to memorize. So I'm going to give you that conversion, and then I want you to pause the video and try to work the problem yourself, and then come back and see if you get it right. The hint that I want to give you is anytime you're going between base units like kilogram to gram, and gram, of course, is the middle unit, always go back to the base unit first because we know those conversions, or I'll give you the conversions, so that way you're not trying to figure out how many picograms are in a kilogram. You already know the base unit for most of these, and so you can just go back to the base unit. So go ahead and pause and work the problem. Okay, how'd you do? Okay, so we started with kilograms. Let's walk through this problem. We start with the kilograms because that's what they gave us in the problem. Remember, whatever unit we write down here, it immediately goes on the bottom on the next step. So our kilograms cancel out. We converted it to grams, but we're trying to get to picograms. So if I want to get rid of grams here, then I would put it in the bottom on the next step. And so then I know that 1 gram is equal to 1 times 10 to the 12 picograms. And then I put that in my calculator. Remember, if it's on the top, we multiply, and then we divide by what's on the bottom. And so when I do that math, I should get 2.08 times 10 to the 17 picograms, which, if we stop and think about it, makes a lot of sense because picograms are really, really, really small. And so it should take a whole lot of them to equal the kilograms. Our beginning answer had 3 significant figures, so our final answer also needs to have 3 significant figures. So this problem is using conversions you already know, so I want to make sure that you know how to do that. So just like before, pause the video, work the problem, and see if you get this answer correct. So hopefully you got 604,800 seconds. And notice that on this one, I did not use my 1 week over here as a determining factor for my significant figures. And that is because 1 week is an exact number. It is not a measured number. So there's no uncertainty in how many seconds are in a week. That would be a known thing because it would be exactly that many seconds in 1 week. All right, I think we only have one more problem, so let's go see what it is. All right, this is another conversion where we're going to different units, so I want to remind you to go to the base in the middle. And so just like before, pause the video, try to work the problem, and see if you get it right. All right, hopefully you got this answer. We should have had the 1,000 milliliters in a liter, so that cancels out, and then liters cancels out because there's 1,000 liters in a kilometer. Remember, kilo bigger than the base unit, so it's always going to take a lot of the base to equal that, and then of course milli is a smaller. Sometimes that gets a little bit confusing for kids because they're both 1,000, but this milli is smaller, so it's always going to take 1,000 of the milli to equal the base. But the kilo is bigger, so it takes 1,000 of the base to equal a kilo. And of course, if we look at our answer, this had, this had 3 significant figures here, so we match our answer with 3 significant figures here. Okay, so let's recap the things you need to know for the test. You definitely need to know your prefixes, but remember you only need to know the ones that I've told you you need to memorize. Any of the other ones I would give you. You for sure need to know the rules of significant figures, both how to recognize the significant figures and how to add and subtract with them. You have those rules in your notes and you can practice, or you can watch those tutorial videos. You need to know how to do the calculations, specifically dimensional analysis, density, and percent error. There is also, if you're still struggling with how to set up a dimensional analysis problem, there is also a tutorial video on my Canvas, and then there are so many tutorial videos out there that you can watch on YouTube. Khan Academy has some great ones. There's several different places you can go to find that. And if you're still struggling, you should watch that over and over, or find one that works for you and make sure you watch that. And then, of course, your definitions, quantitative, qualitative, precision, and accuracy. Please spend at least a few minutes looking at those definitions because they're simple definitions, but what happens is students don't study them, and then they get to the test and they get them backwards in their head, and then they miss problems over something that was really actually pretty easy if they just would have spent a few extra minutes. All right. Stay tuned on the next slide for the jokes. If you don't want to hear the jokes, then end the video here and don't forget to study. All right, here we go with corny joke time. First one, what is Dr. Jekyll when he is himself? Call him dehydrated. What crime did the tree commit? He committed treason. And the last one, what do you call a baby train? You call him a trainee. All right, that's it for today. Make sure you please study for your test, and we will see you on Monday.